This video is on section 3.8, arguments and Euler diagrams. In section 3.7, we did arguments and truth tables. This will be using Euler diagrams to see if our arguments are valid. The time you use Euler diagrams is when you are dealing with quantitative statements like all, some, or none. So here's what we do. The Euler diagrams are basically Venn diagrams. Number one, you make an Euler diagram for the first premise, and then you make one for the second premise on top of the first one. And the argument is valid if and only if every possible diagram that you have drawn illustrates the conclusion of the argument. If there is even one possible diagram that contradicts the conclusion, this indicates that the conclusion is not true in every case, so the argument would be invalid. And a good strategy is to look at the conclusion and find a counterexample within your diagram. So let's take a look at some examples here. I go back and look at just basic Venn diagrams for all, some, and none. This is the Venn diagram for all A or B. All A, that's every element in set A, is contained within the set B. That's all A or B. We want to write a diagram for all pens or writing utensils. So here's my pens located within the writing utensil. So you do want to label these as you draw them. You know, abbreviation is fine. You don't necessarily have to write out all the words. So this is all pens are writing utensils. Two things about all. One is whatever follows the word all goes inside of the word that follows are. So all pens, that's why this is inside, because it followed all, are writing utensils, and that's why that was the bigger set. And the other thing is, think about when you just see for all A or B, think what we're really talking about is all of the A elements are part of B. All of the A elements are part of the bigger B set. Another Venn diagram that you should be familiar with is no A or B, meaning there is no overlap. They are disjoint sets because none of the elements of A are contained in set B. So no dogs or cats. Here's my dog set. Here's my cat set, and they are disjoint, and that shows me no dogs or cats. Some A or B. That's this picture here. Now, color coding wise, it's this red portion that indicates some of the A or B, because these are the ones that are in A, but they are also located in B. So some basketball players are short. So I've got BB players here, and I've got short people over here, and we do have an overlap because some of the basketball players are also contained in the short player set. And sometimes you have to look at some A are not B. That would be this red portion over here. Some A are not B. So this in here we just looked at a second ago, this is the A are B. Well, these A's have nothing in common with these B's over here. So this is some A are not B. So some basketball players are not short. Here's my basketball players, here's my short, and there is an overlap, but what we're really talking about is this right here. All of this not getting into that little overlap portion. So all of this is my basketball players who are not short. So let's look at some examples of arguments. All freshmen take history. The freshmen are going to be the inside set. Those students taking history are the outside set. That's my first premise. Second premise says everyone who takes history takes chemistry. Remember, everyone is the same thing as saying all. So that means the history guys are within the chemistry set. So that's the drawing for my premises. Is there any other way I could draw this? No, there is only one drawing. Now let's see if this is a valid conclusion. Therefore, all freshmen, which are right here, take chemistry. Are the freshmen contained within the chemistry set? Yes, they are, and therefore this is a valid argument. All logic problems make sense. Some jokes make sense. Therefore, some logic problems are jokes. All logic problems make sense. Our logic will be inside the make sense set. Now we have some jokes make sense. You know from some, it's this overlap look. Well, I can draw this two different ways for my overlap. Some jokes make sense. I could do this. There's my jokes. Some jokes make sense, but it might also, in this overlap, come all the way into here. I don't know. Now, it's possible that both drawings will support my conclusion, so I need to look at the conclusion. Therefore, some logic problems are jokes. Well, here's a picture that shows some logic problems are jokes, but this one doesn't support that conclusion, so this is invalid. All silverware are dishwasher safe. So this is silverware in here. They are dishwasher safe. So I'll just call that DS for dishwasher safe. No candles are dishwasher safe. That means the candles have to be totally disjoint from the dishwasher safe set. So now we say that therefore no candles are silverware. Is there any overlap between candle and silverware? No. Is there any other way I could have drawn this? No. So this is a valid argument. All fish are cold-blooded creatures. Some cold-blooded creatures are reptiles, and therefore some fish are reptiles. So fish are my inners. Cold-blooded creatures will be here. Now, some cold-blooded creatures are reptiles. Some cold-blooded are reptiles. You know, some is this overlap. So I could have this, and this is my set of reptiles, and there's my some cold-blooded are reptiles. But there's also this possibility that this overlap comes all the way in here. And now let's take a look at your conclusion. It says some fish are reptiles. If this were the only drawing, that's true. Some fish are reptiles. But look at this drawing. The fish does not overlap the reptiles, so this is invalid. All painters are artists. Some painters are unemployed. Therefore, some artists are unemployed. So all painters, it's my inner set, are artists. That's the outer set. And now we've got that some painters are unemployed. The some painters are unemployed. That means my picture could look like this. Just some painters are unemployed. It could stay totally within the A. Or it could come all the way out here and be my unemployed. Now, what's my conclusion? Some artists are unemployed. If I have this picture, do I have some artists that are in the unemployed set? Sure. If I use this picture, do I have some artists that are within the unemployed set? Yes, I do. So this is the first example where we have seen we had two drawings, but they both support the conclusion. Therefore, this is a valid argument. So do not automatically assume when you have two drawings or more drawings that automatically it's invalid. That's not necessarily true. You have to look at the conclusion for both of your drawings.